Hello again, and we have talked about rational equations, rational expressions. We talked about rational expressions first, and we talked about rational equations, simplifying rational expressions, solving rational equations. Now we're going to be talking about the graphs of rational equations, and you see 4 examples on the board right there. I would encourage you to put these in your parent graphs. I already mentioned them before. The half a volcano and the full volcano. I'm going to write those on there. That's what I call them when I teach my students. This is your parent graph for a rational right here. And this is your parent graph for a rational squared. This is your full volcano. And this is your half volcano. So if you have one in the future, when you have a 5 over x squared plus 7, then you know that it is a volcano because it's a squared function. Here's your horizontal shift of positive 2, so that's 2 to the right. If you had something out here like a plus 4, that would be a vertical shift if you had it. But since you don't have it, we're not going to worry about it. We already went over that in the vertical and horizontal shifts. I'm not going to put these in the parent graphs because this one is just the negative. This is the negative of the previous, and this is the negative of that. So I'm not going to, you don't have to add those to your parent graphs, but just be aware of the first 2. The y is equal to 1 over x minus 2, and the y is equal to 1 over x minus 2, quantity squared. And I'm going to do something here in just a second to show you what happens when you have a vertical and horizontal shift. And that's what I want you to get mainly out of this and the vertical asymptotes. This right here is a vertical asymptote. Vertical asymptotes are real simple. All you have to do is set the denominator equal to 0. Why do you have a vertical asymptote? Well, remember, your domain is affected by 2 things. It is affected by a fraction and a radical. Later on, it's going to be a logarithm, okay? Because you can't take the log of a negative number. You can't have 0 in the denominator, and you can't take the square or the even root of a negative number. So the reason we have, I'm trying to write here. The reason we have vertical asymptotes is because you can't take the log of a negative number. You can't take the even root of a negative number. And you can't have 0 in the denominator. So you can't have these 3 things. So what happens when you have those 3 things on a graph? Then you have an area on the graph that is kind of like undefined. And that's what the dashed line is showing. There is a vertical asymptote, and then there is a horizontal and oblique asymptote. And we're going to talk about 3 things here. We're going to talk about graphing, sketching the graphs, and we're going to talk about vertical and horizontal asymptotes. Now, to find the vertical asymptote, you set the denominator or the radicand or what you're taking the log of, and you set them equal to 0. And then you have to think, okay, what will give me a negative number and what will give me 0 and that kind of thing. And then that is how you find your vertical asymptotes. This right here, you need to make sure you put to memory or you put on an index card. If the numerator has a lesser degree than the denominator, then the horizontal asymptote is y is equal to 0, the x-axis. In this case, you've got x to the 0 here and x to the first, x to the 0, x to the first, x to the 0, x to the first, x to the 0, x to the first. So if the numerator has a lesser degree than the denominator, so this n is less than, if you have n up here, number to the n power and number to the n power, if the denominator numerator, if the denominator is what? If the denominator is higher, so ND is greater than N numerator. If your numerator on the denominator is higher than your numerator, then your vertical asymptote is going to be the x-axis. So in this case, the vertical asymptote, the horizontal asymptote is y is equal to 0. What does that mean? Well, if you, just like before we talked about, remember, I don't know if you've seen my domain and range when I'm talking about functions and the ice machine. You put in 5 gallons of cherry Kool-Aid, you're going to get 5 gallons of cherry Kool-Aid ice cubes. Okay? The range depends on the domain. So if your domain is affected by these 3 guys, then that means your range is going to be affected also. So if you have a vertical asymptote, chances are you're going to have a horizontal asymptote or an oblique asymptote based on the domain. So that's why you have to be able to find both of them. Well, what if they're equal? Well, if the degree of the denominator, if n of the denominator is equal to n of the numerator, then you just take the coefficient of that function. And we'll get into that when we do a couple of problems. We'll get into that. And then what if the numerator of the degree is greater? The degree of the numerator is greater, then you use long division to find the oblique asymptote. So, what I want you to be able to do, and I'm going to erase all this right now. I'm going to go ahead and pause the video if you need to write any of what I just wrote. But I'm going to erase it so you can finish, so you can pause the video and you can write down this information on the index card or your parent graphs. But I would highly suggest that the right side of this screen you write on an index card. You can add the graphs over there to your parent graph that we went over with vertical and horizontal shifts. But anyway, I'm going to erase this now. There we go. Oops, I'm sorry. I didn't mean to erase the whole thing. Let me go back. I'm going to have to because I can't. Let me go back and see if I can. Let me try this and hit delete. Nope, it's not going to let me do that. Try one more thing. Let me try delete now. Delete. There we go. And I don't know what I can delete here, but I can delete. No, come on. There we go. Delete. 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 I think, let me get this. Delete. There we go. Sorry about that. One of these days I'm going to get training on this board. Now make sure you have the information. I just erased all that information, but hopefully you paused the video before that. Now again, the 4 graphs on the left, that ought to be in your handy-dandy parent graph. From this video, we talked about vertical and horizontal shifts. And the right side here, you need to pause the video and you need to transfer that to a index card. Okay, so I'm going to go over here to the next page, and I'm just going to draw I'm going to put a algebraic function up here. I'm going to say f of x is equal to 1 over x minus 2, x squared minus 2, quantity squared plus 4. Now at this point, oops, that's not you don't have to do square right there. Sorry. There we go. Okay, at this point you say to yourself, okay, this is a squared function, or you can put the square here. You don't have to have the square. You can have the square out here. Remember, x right here, x minus 2 quantity squared, c. Just making sure everybody knows what I'm doing here. Okay, so here I'm going to highlight this guy, and I'm going to highlight this guy, and I'm going to highlight this guy. Oh well, thought I was going to highlight him, but there. I'm also going to highlight the 1 up there because if I highlight him, you'll look at him too. So I'm going to use a magenta on him. Okay, now what are these things? Well, technically that 1 is an A. Okay, but you know, you don't recognize it because it's up there, but you could have a 1 there. You could also have an A here. So I'm just going to say A is equal to 1, and we won't highlight it there. We'll highlight it right here. We'll put A. And now I'm going to highlight it there. All right, so we've got this 1 tells us a regular volcano, and the reason we got a volcano is because of this guy right here. That's a 2, so that means we got a volcano. The 1 tells us, okay, it's regular, so it's not going to be compressed, it's not going to be stretched. We've got a horizontal shift of 2 to the right, and we've got a vertical shift of 4 up. So what we need to do is bring in my handy dandy there we go. And I'm just going to draw a straight graph. I mean, not a graph, but a... Now, I know that my regular function, and I'm going to do this in a real faint yellow. I know my regular volcano looks something like this. Okay, I know you can barely see that, but I don't really want you to see it. I just want you to look at your parent graph, and I want you to think, okay, 1 over x squared looks like that. Okay, now the 1 right here, the magenta, it tells us that nothing changes there. There's no compression, there's no, here, I'll do this, maybe you can see it better. LSU colors. There's my volcano. The 1 tells us that there's no compression, no stretching, no compression on the x-axis or y-axis. So 1 tells us that. But that negative tells us we got to go 2 to the right. So we're going to do 1, 2. So now my origin is at 2 to the right, and it's also going to be 4 up. So take my yellow marker and go 4 up. 1, 2, 3, 4. So this point right here is our new origin. So I'm going to draw a new x-axis right there, and I'm going to draw a new y-axis right there. And now I'm going to take a new color, and I'm going to just use something. I'm going to use red, since I don't use red very often. And now I put my new graph right here. The red graph is my graph showing this right here. Now I can also find my vertical and horizontal intercept. My vertical and horizontal asymptote. My vertical asymptote, I'm going to set x minus 2 equal to 0. X cannot equal 2. So there's my vertical asymptote. And that's represented by that right there. So that means x is not, I cannot use 2 in that function, okay? I cannot use 2 in that function. So what I do now, as far as the horizontal asymptote, well, the horizontal asymptote is based off the degree of the numerator and the degree of the denominator. Actually, it's squared because that's x minus 2 quantity squared will give you x squared minus 4x plus 4, okay? But 1 or 2, if you put this here, it's going to be a 2. But I don't care about that. Either way, the 2 is greater than the 0. So since x, I'm going to compare x to the second compared to x to the first. And 2 is greater than 1. Therefore, the degree of the denominator is greater than the degree of the numerator. So we have a horizontal asymptote of y is equal to z. I'm sorry. Yeah, 0, except it's moved up 4 places. 4 places. Horizontal asymptote is 4. Okay? So that's how you do that one. Now let's do another one. Let's do one and it's not let's do this one. F of x is equal to 1 over x plus 2 and then plus or minus 4. Minus 4. Okay, this is not 1 over x squared now, it's 1 over x. So let's go to our parent graph. We know that, I'm going to put a parenthesis around this so I can put a 1 out here because there's nothing there, so it's soon to be 1. So let's do our highlighting. There's our orientation, meaning nothing's changed. And then we're going to highlight this guy. That's a horizontal shift of 2 to the left. And then we're going to highlight this guy, a vertical shift of -4. So at this point, we pull in our handy-dandy graph paper again. And I'm going to draw a and here we go. We know that the function 1 over x, this is the parent graph. The parent graph for this function is 1 over x because it's to the first power, okay? Our previous was raised to the second power because we had x plus 2 or whatever to the second power. This is to the first power, So we know that the parent graph for this one looks like this. So now the origin for this graph is right here. So now I know that we're going to have 2 to the left, horizontal shift, and a vertical shift of 4 down. So now I'm going to go 2 left, 1, 2, and 4 down. 1, 2, 3, 4. And there is my new origin. So I draw a new y and x axis. And now I redraw, and I'll do it in red. And I'll make it a little bit thicker this time. Let me make it thicker. And now I draw the same graph, since it's 1. I draw the same graph, and it's right there. So again, you see that there's no difference between the graph. The only thing we have again is a vertical and horizontal shift. And that's how you do that graphically, okay? And you can always check with your graphing calculator to make sure that you've drawn it correctly. Now, let's go with vertical and horizontal asymptotes. If when you don't have a graph, when you're not graphing, how do you do it algebraically? Well, let's say you have f of x is equal to 1 over x minus 2. Well, here again, you have x to the 0 up here, and you have x to the 1. So in this case, the degree of the denominator is greater than the degree of the numerator. Therefore, you have a horizontal asymptote of y is equal to 0. So that means that the x-axis will be the horizontal asymptote. So you're going to have a function that looks like this. Instead of it being right here, you're going to move it over 2 places to the right, and it doesn't have a vertical shift. So now our new origin is right here, and the actual function is going to look like this. And there's the new function. Well, what if you have it the other way around? What if they're equal? F of x is equal to 2x minus 2 over 3x plus 1. Well, first you got to find your vertical asymptote. Vertical asymptote, 3x plus 1 is equal to 0. 3x is equal to negative 1. X cannot equal negative 1/3. That's your vertical asymptote. So at this point, you draw an origin, and of course, this is going to be kind of like before, only this time you have a vertical asymptote at negative 1/3. So there's negative 1, negative 2. Negative 1/3 would be right here. So I've got a vertical asymptote at 1/3, and now I got to find these two, the degree of the denominator. The degree of the denominator is equal to the degree of the numerator. Therefore, I have to use the coefficients of the function, which would be these two guys right here. So my horizontal asymptote is equal to 2/3, which means I've got to go up 2/3. Let's see, that's 1, that's 2. 2/3 be right here, and there is that. Now I do have it, it's going to be kind of a function, I don't know what it looks like, but it's going to look something with this quadrant and this quadrant Why? Because that is a x to the first. Now you'd have to check it on your calculator, but it's going to be a variation of this right here. And that's how you find your vertical and your horizontal asymptote. Okay? Again, this one, the horizontal asymptote was 0 because that 1 right there is greater than that 0. If they're equal, you have to use the coefficient. Now remember, I'm not teaching this for the first time. This is stuff that you should have seen before in Algebra 1 or Algebra 2. And then, of course, the last one is when you have f of x is equal to x squared plus 3x minus 2 over x plus 1. And here you have the degree of the numerator is greater than the degree of the denominator. And when you have that, you use long division. And that's going to be x plus 1 into x squared plus 3x minus 2. And x will go into x squared, x times x is x squared, x times is 1x. You always subtract. And that's going to make this a negative and this a negative. That always goes out. 3x minus 1x is 2x. Bring down the 2 to help out. How many times will x go into 2x? 2 times. 2 times x is 2x. 2 times 1 is 2. You always subtract. And that's going to leave you with a -4 remainder. We really don't care about that. All we care about is that. That means we've got a function that's going to not only have, we got to find the vertical asymptote. Vertical asymptote is x plus 1 is equal to 0. X cannot equal -1. So there's your vertical asymptote, -1. And then we've got a oblique asymptote. I can't spell asymptote worth a flip. Asymptote. Okay. X plus 2, that means a vertical shift of 2 up. And a 1-to-1 function, which means a 45-degree angle. So you might have a function that looks like this, or some variation. And that's how you find the vertical and horizontal asymptote, whether it's on a graph with a vertical or a horizontal shift, or whether you found it algebraically. Now remember, you've got to go back to those 2 right there. And I'm going to leave those on the board while you, as I finish this video. Remember, the 4 on the left, the 2 on the left, these 2, A and C, those should go in your parent graphs. I think I've included them on your parent graphs. And B and D are the inverses, or the reciprocal, not the reciprocal, the opposite sign of A and C. So they're just going to be the flip-flop. And finding your vertical and horizontal asymptotes are on the right-hand side here, and I would put that on an index card to remember in case you forget. And that concludes rational functions, whether it be in a rational equation, a rational expression, or the graph of a rational expression or equation.